One of the major problems we've had with paper is that there's so much of it. One of the largest benefits of ShopFloor 2000 is that we can eliminate, if not all of the paper, most of the paper on the shop floor.
ShopFloor 2000. It's a corporate-wide program to dramatically reduce the stacks of paperwork required to build our products. Hello, I'm Donna Race. ShopFloor 2000 is one of many initiatives to streamline processes, to establish common management systems across the entire organization, and to move us toward the factory of the future. We'll continue our examination of the factory of the future, and we'll talk with John McDonnell about our merger with the Boeing company in this final edition of Flight Times TV. In our business, we have to document everything we do on the shop floor. And we need work orders, schedules, engineering drawings, assembly instructions, process specifications, and on and on. And that means paper, lots of it, with just as much opportunity for it to get lost and for making errors. We've begun to tackle the paper problem with ShopFloor 2000. It's a computer-based system that delivers work instructions to shop floor mechanics electronically. It's much more efficient than paper, and according to Program Director Bill Coop, it'll improve productivity.
In the past, mechanics have had to go from area to area, place to place, to look for blueprints, to look for process specifications, to look for tooling requirements. Now we can provide that data all in one source. On the computer are work instructions, just like they were in the past, only not hard copy, they're what we call soft copy on the computer. Simply through the PC technology with the mouse, they can point and click at data that they would like to access, for example, process specifications. We'll have right on the work instruction, line item by line item, the process specifications that they need to do their jobs. Another thing is they can, line item by line item, we have engineering drawings right on the work instruction that they can click and pull up the engineering drawing so that they don't need to go to a blueprint crib. It also provides us efficiencies in terms of the data that's sent to the shop floor. For example, engineering changes. We can send schedule changes to the shop floor. We can send data like that to the floor quicker, faster, and what that means is cost reduction, and that's what the name of the game is in today's business.
ShopFloor 2000 can also capture the mechanic's hands-on experience, expert knowledge that can be incorporated into work instructions. Video images can be added to help the mechanic perform a particular build sequence. And as the system is deployed throughout the corporation, it will support the seamless transfer of work from one facility to another to make better use of people skills and shop floor capacity.
What ShopFloor 2000 gives us is the ability to transfer work and not have to retrain or replan the work that's transferred. And if you have the same look and feel of a computer system on the shop floor in one site that looks and feels the same at another site, we get significant learning and significant cost reduction when we transfer work.
ShopFloor 2000 is already operating in some production areas on the C-17, MD-11, and MD-80 programs. The goal is to achieve full deployment by the end of 1998. One thing is very apparent in the factory of the future: the increasing use of computers. For years we've used computers to design and engineer our products, but today's advanced software and increased computer power give us the ability to design and engineer in solid three-dimensional images. Those images can be turned into virtual reality simulations of the real product. They're doing that in a program called Design, Manufacturing, and Producibility Simulation, or DMAPS. John Coyle directs the program.
You know, we're doing a lot of work now in defining our products full 3D, so you can visualize what's going on. And it's where virtual reality comes into that, is it allows the engineers or supportability or maintenance kind of folks to interact in that environment in a virtual environment. So, you know, the same kind of thing you can do with a physical mock-up or the product, you can simulate that, or you can do a rehearsal of that in the virtual environment, which is just a computer generation.
3D solid modeling and virtual simulation make true concurrent engineering possible. Critical design and manufacturing disciplines can work together in a virtual environment to make sure the product is supportable, maintainable, and goes together like it's supposed to. Even the assembly process and tooling can be simulated and refined before anything real is ever built.
We're trying to integrate in a kind of a seamless environment all of the engineering tools and manufacturing tools that we use for product definition. We use the virtual manufacturing tools, which allow me to simulate the assembly of the product. They allow me to simulate the fabrication processes. We try and do that in the conceptual layout phase of the program, because that's where you lock costs in, and that's where you need to figure out how you're going to build the product. So we try and, you know, simulate the way we're going to build it while we're designing it to make sure it's producible, which reduces the upfront acquisition costs. But we also want to make it more supportable, which addresses life cycle costs and makes it easier for our customers to use it. So it's cheaper to buy and it's cheaper and easier to support.
Reducing design cycle time and rework are obvious benefits of computer simulation, but there's potential for others too. For example, in redesigning the T-45 horizontal tail from a metal to a composite structure, engineers first simulated the manufacturing process.
That same sort of simulation we can capture in the form of visual aids, so we can deliver to the shop floor a recorded simulation that shows the production worker a really good visual demonstration of how those products go together. And we're working that right now with how to integrate the visual aids from simulation into the overall shop floor 2000 concept and IMAX, and how that all really plays together.